We are looking at chemistry practical for today, and we're going to be looking at a particular past question for Oyo State promotional exam. Number one, when we are talking about chemistry practical, we are looking at two major concepts, or we are looking at three in most of our O level. The first one is one they call quantitative analysis. Second one is the one they call qualitative analysis, and this qualitative is the one that we mostly call it SWOT analysis. While the third one is the general use of laboratory, like basic questions on things we should do and things we should never do in the laboratory. So the majority of the questions are under this, majority of marks, we have it under the quantitative, so which is basically called titration. When you are looking at this question, there are a few things that you should know. Number one, you should know that here we are dealing with amounts. We are looking at amounts of something that we add to another thing. And when we are looking at this amount, the most important thing there is that there must be a balanced equation. So when you have written your balanced equation, you look at amount of A that you are adding to a particular amount of B and the amount of C that you will get, which is your product. So when you look at the amount, there are about three ways we can see amount. Number one, we can look at amount in terms of mass. We can look at amount in terms of volume, and we can also look at amount in terms of something we call number of particles. So I'm going to be using just this to denote the number of particles, the NP. Now, this mass, volume, and number of particles, they are not generally accepted by scientists. Scientists have formed another one which we all accept, and that one is the one we call number of mole. Number of mole. So the number of mole is there with symbol N, and it is measured as MOL. We must be able to convert mass to mole and convert mole to mass, volume to mole and mole to volume, number of particles to mole and mole to number of particles. So how do we do that? Number one, you divide mass by molar mass. You divide volume by molar volume. Why we divide this one by a constant introduced by Avogadro, which we call Avogadro's constant. So let me change mass to number of mole. Number of mole is mass over molar mass. Let me change volume to number of mole. Number of mole is volume over molar volume. Let me change number of particles to number of mole. Number of mole equals to number of particles over number of Avogadro. These three formulas are the basic that everybody must know. Apart from this formula, there is another one that has to do with concentration. So we have already said it, like I think in one of the videos I posted last night, I showed that when we think about concentration, we are trying to talk about amount in a particular volume. We have said that, and the volume must be in DMT. I think we talked about that. So the amounts that we are talking about can now come in two ways. Number one, our amounts can either be mass, and number two, our amounts can either be mole, number of mole. So it means that when I'm talking about concentration, the amount can be mass or the amount can be mole, the volume remains. If the amount is mass, I will say mass concentration. If the amount is mole, I will say molar concentration. So if everybody notes these three, you can go back in order for you to really have better understanding of these three, or you memorize them. The number of mole is mass over molar mass, number of mole is volume over molar volume, number of mole is number of particles over number of Avogadro. So I'll clean this, and then I will now start from the concept of the concentration. So again, if I write the formulas for the number of mole, I have it that number of mole equals to mass over molar mass, number of mole equals to volume over molar volume, number of mole equals to number of particles over number of Avogadro. Now note, when I say number of particles, I mean number of ion, number of molecules, number of anything, radical, number of electron, number of proton, number of neutron, all of them are called number of particles. So what we are going to do now is that concentration. One of them we are going to be saying mass concentration. Why am I using the word mass concentration? If my amount is measured in mass, so that means that I put a particular mass in a given volume. So it means mass concentration equals to mass over volume. And again, another name that I'm going to be given to this mass concentration is based on the unit. What is the unit of mass? Gram. Unit of volume? dm³. So I can be saying again that mass concentration is also known as concentration. Concentration in gram per dm³. So I think this should be clear to everyone. So these are the two names that we call mass concentration. Mass concentration can also be called concentration in gram per dm³. So again, the second concentration that we have is if our amount is not mass, but it's rather number of mole. So I am going to be using the word molar concentration for that one. And that's going to be equal to number of mole over volume. So here, if our C equals to number of mole over volume, then that means that number of mole equals to concentration times volume, CV. So number of mole equals to concentration times volume. Now, we can also use the unit to name this guy. Where here is mol mole and here is dm³. So that means that our mass concentration can also be called concentration. Concentration in mole per dm³. Then another name that we can also call this guy is molarity. So three names for one quantity: molarity, concentration in mole per dm³, molar concentration. So these two concentrations are very important and they are part of the first question that we always expect in an exam. So we are going to take off this and we are going to show something. That mass concentration is the same. Mass concentration is equals to mass over volume, we remember. Then molar concentration is equals to number of mole over volume. So we need to remember these two quantities very well. And we should be able to also establish the relationship between them, between mass conc and molar concentration. So let's look at the relationship that we have between the two of them. And that relationship, I'll just write the formula out. Okay, without writing the formula out, let me quickly remind you how we come across the formula. We say mass conc is equals to mass divided by volume, right? While we say molarity is equals to number of mole divided by volume, then we have to know that the only difference here is amount, which is mole and number of mole. Mass and number of mole. Now, what relates mass and number of mole? That is number of mole equals to mass over molar mass. What I want to do now, I label this equation 1 and I label this guy equation 2. Now, I call this one equation 3. And from this equation 3, I make mass subject of formula. Mass will now be equals to number of mole times molar mass. So, simply from this simple illustration here, I can say that put mass equals to number of mole times molar mass in equation 1. You can see from here, anywhere I see mass is number of mole times molar mass. So therefore, what do you think? Mass is now equals to what is mass from here? Number of mole times molar mass, right? Divided by what's on